Now I would like to welcome our first keynote speaker, Uwe Friedrichsen. Uwe is a long-standing and valued iSAQB member, and he is one of the best known and finest minds in the software architecture community. You can now look forward to his opening keynote entitled "The Future is Already Here, Mastering the Challenge of the Coming Years." I hope you enjoy it and that you gain many exciting insights. Thank you for your attention, and I now hand over to you, Uwe.
Thank you. I hope everyone is able to hear me. And well, I will switch over to my PowerPoint screen over there. Yes, I'm still using PowerPoint, doing that for 30 years meanwhile, and used to that. And so if anything goes wrong, please phone to the moderators, interrupt me. My microphone should work because that's a cable-bound headset and stuff like that. So at least I should hear you then. Okay, welcome to everybody, and thanks a lot to the organizers for inviting me to this keynote. No, even if I wasn't a program chair, I didn't invite me to the keynote myself. That's not possible here. So just to be clear about that. And thanks a lot to all of you who are willing to listen to this. What do I want to do today? What I would like to offer you in the next 45 minutes is offering you a little bit of a bit different perspective regarding how to do IT and how to organize IT. I will not dive so deep into the implementation details. I mean, we could discuss that for hours, days, weeks, months. Probably would need months to discuss that all through, but obviously we don't have the time for that. So it's more about the underlying ideas, the concepts that you can use to navigate your decisions in the future if you want to. And if you ask yourself how that strange title fits in, the future is already here, I will come back to that one at the end of the talk. My name is Uwe Friedrichsen, and I work for Concentric. It's a still relatively small IT company, so software development and consulting, located in Germany. And on the internet, you can find me usually with my handle Ufried. The IE in German is usually pronounced as you would write it in English with a double E, something like that. So that's Ufried. Then you find it on Twitter or X, how it's called meanwhile, and on Mastodon and on Blue Sky, and also on Speaker Deck, where you can download my slide decks. And I also write a blog, ufried.com, where I share some of my ideas and hopefully insights. But okay, let's get started. So if I say I want to offer you a different perspective, a new kind of framework, mental framework to ponder things and so on, the first question usually is, why? Why should I use something like that? Or why do I need it? And from what I see, we face quite some challenges in IT these days. Sorry. Hope that's better now. Quite some challenges in IT these days. Well, a lot of them, but there are three of them which I think are the most important ones and which will affect us most in the upcoming years. And if we're able to handle them properly, I think many of the other challenges will not be that hard anymore either. Okay, what are these challenges? The first one is our world has gone VUCA. VUCA, that acronym for volatility, uncertainty, complexity, and ambiguity. So volatility meaning that things change dynamically, everything happens at faster and faster pace. So uncertainty that, we do not really know anymore what's going to happen next. So this lack of predictability, and then complexity, the loss of clear cause-effect relationships, which means that this long-term upfront planning, these divide and conquer tactics and all that stuff doesn't make too much sense anymore. And finally, ambiguity, the unclear meaning of signals. So what I think that I see, is it really what I see, or does it mean something different? And so also not being clear about that. And that affects many of our companies and also us in IT a lot. And there are a lot of drivers for this VUCA. And I think the biggest driver of that is so-called or what at least I call post-industrial markets. And to explain post-industrial markets, we have to go back to the last century to industrial market, industrial production, to understand them better. And industrial production always was focused on maximizing efficiency, so producing more, using less money for producing things and so on. And why did they do that? Because if you go back to the very beginnings of industrial markets in the early last century, there was an implicit assumption which was underlying basically the foundation of all these principles that evolved from that is that demand is a lot bigger than supply. So people wanted to buy your stuff. But even later, still, that there was still enough demand. Still, people wanted to buy your stuff. Whatever you did, whatever you offered, what your service or your product, whatever it was. And so there's a certain certainty that you will sell whatever you produce. So, and just to be clear, selling is creating value. That's your outcome. Producing is output. It's no value created yet. But still, because you know whatever you're producing, you're also going to sell, well, then the best thing you can do is produce more, because then you sell more, and produce it at a lower price, because then your profit becomes bigger. Easy story. I mean, we all know that. We know it until today, these principles. And everything was built on top of that. The whole industrial production principles and so on, they're all based on this underlying foundation. The problem is that most markets these days are different. The relation reversed. These days, usually supply is a lot bigger than demand. And this creates a bad situation for us as producers, because our customers do not simply buy anymore just because we produce something. Well, they only buy from us if we meet their needs best. And that means that all our competitors, including us, are running a Red Queen's race, figuring out what are their ever-changing needs and demands. And this creates a highly dynamic market and basically an unpredictable market behavior. What will be the next thing? How do we need to change to adapt and so on? And even our customers do not know. They only do know it when they see it. So you can ask them up front, but usually say, I don't know. Or they say something and then they buy something different or whatever. So it's a completely different situation then. And yeah, there are also non-efficient, so some exceptions for non-efficient markets. So markets where there's no real competition due to regulation or to lots of lobbyism or oligopolies or anything like that. But let's leave them aside. Most markets are post-industrial markets these days. So, and that's VUCA. So it's highly dynamic, it's uncertain, it's complex, its signals ambiguous, and so on. And there are also some other developments like the geopolitical developments. We see a shift in power structures, economic and political, and we don't know where it's going. And there's also things like the climate crisis and its effects and so on. And yeah, we also don't know where it's going, basically. Nice animation, went wrong. Okay. Anyway, and there's a big multiplier in there for all these effects of VUCA that we have to deal with. And that's this continuous over optimization, this aim for more and more and more and more efficiency. I mean, you can gain a little bit more efficiency. There are some low hanging fruits, but everything that you want to achieve after that means you have to reduce variance. So there's some expected range how things are going to happen, when things will arrive, what quality they will arrive in, how long it takes to process them, and so on. So, and you try to reduce that variance further and further and further. So TQM, Six Sigma, and all these quality improvements methods, they're all about that, reducing variance. And that's great for becoming more efficient, for producing more with less money. Again, industrial paradigm. But whenever something outside the norm happens, these systems have a big problem with that. They're really rigid and they don't like it. And the problem is VUCA means outside the norm becomes the norm. So surprises are the new normal in a VUCA world. And these systems have a real problem to deal with that. They deal very bad with it. It takes them a very long time to recover from kind of adverse, unexpected events and all these things. I mean, just remember there was a ship lying, blocking the Suez Canal, and for 6 months, all our supply chains didn't work properly anymore. And that's over optimization. And so we have a multiplier in there. So wrapping the VUCA world up basically means these days, let's skip that for a moment. Planning, well, yeah, you can plan, but do not expect your plan to stand the test of time until maybe a few weeks or something like that. So 5 years plans, you can do them, but better do not expect them to work. Convictions, so these hippo-driven decisions, so highest paid opinion in the room, saying, I think that's the best thing to do because I'm convinced we should do it this way. Well, that's a bold bet. Maybe also your last bet. You don't know. In a VUCA world, that's bold. And best practice do not exist, not even good ones. We live in a world of probe, sense, respond, or inspect and adapt, or build, measure, learn, or however you name it. So short feedback cycles with the market, continuously learning and adapting. That's VUCA. Now you may ask yourself, well, that's interesting, but what does that have to do with IT? Well, that's the next challenge. IT has become indispensable. And that's coming from this badly understood thing which is called digital transformation. I mean, most people that I see still get it wrong because digital transformation is nothing new. Digital transformation is more than 60 years old, meanwhile. I mean, we started with digital transformation in the late 50s when we started to implement selected business functions and support them with IT systems, report here, analysis there, something like that, small things. Computer hardware wasn't that strong back then. And then later on, so in the mid 70s, early 80s, computer became more powerful. Later on, we got networking and personal computers and all that stuff. We started to support whole business processes. I mean, it was also the beginning of SAP systems and all these kind of standard software and then with the rise of the internet and with the World Wide Web, to be more precise, and e-commerce in the late 90s, we also built IT into our customer interactions. And then, more recently, we start to create whole business models which are based on IT, which do not work with IT. Let's start a little bit earlier, but also which is without any humans in the loop. There's the whole revenue stream of the company just going through an API. For instance, think about Stripe as just a simple example. And there are a lot of these things emerging right now. And it's not only that IT is going to support all these things. After a while, IT starts to become dominant. For instance, look at business processes these days. In most companies, humans do not tell the computers anymore what to do next. Computers tell humans what to do next. So here's your inbox, here are your tasks, please process them, and I take care of the rest. That's what's going to happen. And it's a continuous evolution. And if you think that through, this ongoing digital transformation, and you go back to now, 2023, you realize these days, business and IT have become inseparable. Business is IT, IT is business. Same side of the same coin. And on the other side of that coin is the market, and there are your customers. So if I hear people talking about business IT alignment, I always ask myself, where the heck have you been the last 20 years? That was a discussion from the early 2000s, but it needs to be done today. Tendency is rising, and you can't change business anymore without touching IT. And it also means that, well, the way you treat your IT is the way you treat your business, which most companies haven't realized yet. I mean, if you treat your IT as a cost center, in the end, you treat your business as a cost center, like it or not. And it also has another effect, because this ongoing digital transformation means that IT has become an effect on the well-being of human lives. So it has become indispensable for our business and private lives. Shut down IT and you have chaos on the streets, not figuratively, literally. And it's getting more and more. So we didn't ask for it, but these days we have high responsibility for other people's well-being, and in the worst case, even for other people's life. And that means, yeah, you know the Peter Parker dilemma. With great power, you get great responsibility. We have the power. We didn't ask for it, but we have it. And we have to live up to it. And we have to live up to the responsibility we have. And what are people doing if they realize that they have a lot of responsibility? Yeah, of course, so let's get everything out of control. And that's what we are doing, unfortunately. Our complexity is growing uncontrolled. We're drowning in complexity. And if you ask people, yeah, why are our IT systems so complex? Then sometimes you get answers like, yeah, well, these are these CV-driven software development people, or this ongoing digital transformation. And yeah, maybe there's a bit about that. But I do not think that's the real driver. The real drivers of complexity are other things. Like, we're trying to solve non-tech problems with technology. We are doing that all the time. Oh, we have a problem with our organization. Let's buy a tool. Yeah, we want to become agile. Let's buy a Jira. We don't need Jira to become agile. I mean, maybe it supports us, but first let's become agile and then buy Jira or anything like that. Yeah, we want to do DevOps. Let's buy Kubernetes. No, it's DevOps is not about a Kubernetes and all these things. And we're running always for the next technology hype because there's a multi-million-dollar industry out there which tries to tell us, hey, here's new stuff, here's new stuff, new stuff, because otherwise, yeah, well, people wouldn't sell that master. We have these cleanup initiatives. So when, oh yeah, our IT landscape is a mess, let's clean that up. Here's this new, cool, shiny paradigm these days, microservices, and let's rewrite everything as microservice. And we all know, at least people who are a little bit longer in the market, this never works. I mean, it only works until the next CIO comes along or the next fashion comes along. And then you have another layer in your IT landscape lasagna, incomplete, broken, ruins everywhere. And yeah, then you can drill down from time to time and see in the archaeology, oh dear, that's still running down there. And yeah, and everything doesn't integrate well and so on. And complexity multiplies. And of course, this efficiency obsession. And the worst thing, I think, is also this project thinking. I mean, the definition of project is in some ways, let's try to get stuff done in time. So the stuff that we have to do in time within budget. Let's not care about anything that happens left or right. Let's not care about anything that's going to happen after the project end date. It's putting on our project blinkers and just focus on that. And which always leads to situations where left and right suffers or future suffers and stuff like that, because we did some local tweaks which saved us some time or a little bit of money or anything like that. And multiplying complexity and all these things lead to high degree of unwanted, unneeded complexity in our system landscape. So basically, we don't know anymore what our IT landscapes do. And yeah, sometimes we only can guess why they're running. Why is that stuff running? I have no clue, but better don't touch it, because if it goes down, I have no idea how to bring that back running. And we can only guess how to evolve those things, because, well, if we don't understand them, yeah, we don't want to touch those stuff. And how are we going to solve these problems? Yeah, we add more complexity. Hey, let's add this new cool technology. It will solve all these problems magically. Here's a new architectural paradigm. It will solve all the problems magically, and so on. Well, it doesn't. Sometimes I think IT these days is like Wile E. Coyote, again running over the edge of the cliff, slowing down in that second before looking down. And we all know what happens if Wile E. Coyote is looking down. And I'm afraid that's where we are sometimes. And yeah, we don't want to fall down. So the question is, what can we do about that? So what are the possible answers to these challenges, to an increasingly unpredictable world where our IT has become indispensable while we're drowning in complexity? What I want to offer you is things that came to my mind when I thought about these things. And let's start with indispensability. And I think a sensible response to indispensability, because it needs to run, is sustainability, going for the endless game. And if you read sustainability, you may think, oh, well, what's got green IT to do with that? Well, sustainability is much more than ecological sustainability, green IT. Sustainability, if you look it up, has several dimensions. So, of course, it has an ecological dimension. I think it's important to think about the ecological dimension about green IT, because we are creating these many greenhouse gas emissions. Meanwhile, chances are that in 2 years we are creating more greenhouse gas emissions than car transportation and aviation together worldwide. And yeah, we don't want to be there. And so thinking about that makes a lot of sense. But it's also about economical sustainability, surviving in the long running, going in for the endless game. And again, our IT needs to be up and running, not only today, not only until the quarterly report, it needs to be up and running for the next years and years and decades and so on. And so economics sustainability, I think it's a good idea. The next one is also, this includes social sustainability, making things sustainable for the people involved. Because if you create a burnout factory, well, economical sustainability won't be that good. And yeah, in for the long run, I doubt it. And as we are in IT, we also need technical sustainability. So we need to create dependable systems we can rely on, which are up and running, which are safe, which are secure, and. So all these things. And sustainability alone, if you think about sustainability, and how we do make decisions in most IT departments and companies these days, you already figure out there's a different way of thinking about things. Okay, let's move on to VUCA. If everything becomes unpredictable, if surprises are the new normal, what can we do about that? And I think it's quite obvious. It's resilience. I mean, resilience is exactly about that, to be able to handle such situations. The problem is that most people misunderstand resilience, because has become fashionable and everything is resilient somehow these days. And a lot of people I'm talking to, when they talk about resilience, they actually mean what I call stability. So they talk about maximizing mean time between failure or mean time to failure or stuff like that. So trying to make sure that systems never fail. Well, yeah, in the 1990s, that was a good approach, with quite isolated, monolithic, big systems only talking via batch interfaces. But in these days, highly complex system landscapes, highly interconnected, distributed system landscapes, multiplying the effects with approaches like microservices and the like, and, you can only prolong your mean time to failure that much. You can't stretch that eternally. Things will fail, guaranteed. And if you try to keep up the availability, then the only chance you have, because you can't make that arbitrarily long, to reduce your mean time to recovery, how long it takes to recover from a failure. Because the ratio between the two, the mean time to failure and the mean time to recovery, basically determines your availability. And so what you're doing is you think about what can go wrong and how can I recover as fast as possible from all these adverse situations. And it's a different way of thinking that's thinking about stability. And so thinking about stability is not wrong. You need to do that to a certain degree, but you have to accept the limits of it. And then you have to think about how can I shorten the mean time to recovery times. And then you get to robustness. And it's basically the foundation of resilience, because you need robust systems for becoming resilient. But it's still not resilience, because no matter how good you think about all these things that can go wrong, you will miss some of them. So you will be hit by surprises, by unexpected adverse events. And then you need to learn how to respond to those. Because, it doesn't help if you say, yeah, well, I expect something like, that something becomes laggy down there and I'm able to handle timeouts, but okay, now it's an overload situation. I have no idea. System went down. Yeah, let's create a task force for that and fire up our regular processes, how to handle that. And yeah, it's 2 weeks until we set up the project board, and doesn't work. And so, or everyone's running around screaming like chickens or something like that, like with the fox in the henhouse, and nobody's knowing what's going on. And you need to have a plan how to address that, and you have to be some training and so on. And there are 2 things that are important to note if we talk about real resilience. The first thing is you can't build resilience only into your IT systems. You need the humans there. You need to consider the whole socio-technical system. Processes, organization, and IT systems working together. So IT systems doing the robustness stuff, delivering the observability needed to make good decisions, and the humans in there being able to handle the unexpected situations and get good information and have good ways to interact with their systems and bring them up and running again. And the second thing, which is very important to understand, is that resilience and efficiency are sort of antagonists, because efficiency tries to maximize utilization of everyone involved, 100% minimum, 150% better, 210% even better, and so on. And so with how little capacity am I able to survive? Isn't everything breaking down? But if you know queuing theory, you know that if especially if humans are utilized to the max, things take eternally until they happen. So it takes longer and longer and longer. The people do not have the capacity anymore, the slack, the wiggle room, or anything like that, call it how you like, to handle surprises, because they're all busy with doing their daily work. They're already overstrained with doing that stuff, because they get always more work than they can do. And so you have to leave some capacity, some wiggle room to handle unexpected events. And that's the problem with the over-optimization too here. By the way, there's one more level that you can achieve. That's basically anti-fragility, which also part of resilience. So that you do not even only recover from these events and stuff like that, but you even improve and maybe even thrive from adverse events. So you're better off after the event than you were before. Now, Nicholas Taleb insisted that anti-fragility is something different than resilience, but that's due to the definition he made of resilience. So if we look at the possible responses, so resilience can mean to withstand, simply standing there, withstanding the adverse events. That's more about stability or to recover quickly. So you're fall over, but you get up very quickly. That's more about robustness. But it also means that you are able to adapt. So that say, okay, these kind of failures, these kind of adverse situations happen more and more often. So let's get out of the way and change in some way. Or let's say, no, it doesn't make any sense anymore to remain here because that's become a terrible place. So let's reinvent ourselves. So go somewhere else. And that's basic transformation. And all that belongs to resilience. What Taleb did, he made a definition, said, yeah, resilience is just withstanding and recovering. And the other two things do not belong to resilience. And by the way, he was the only one who did this kind of definition of resilience. I went through about 2 or 3 dozen definitions of resilience from a lot of domains, not only the technical ones, but all the other domains. And all the other definitions said, well, adaptation and transformation also belong to resilience. And so, so it belongs to resilience. Okay. And we can play that at different levels. IT systems, again, we can achieve real resilience at IT system level. We can achieve robustness at best there. We can play it on the organization level, on the division level, on the company level, and blah, 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 up to the supply chain. And if you think about resilience and sustainability, say, well, yeah, that's quite different. How we would make decisions in our IT organization about our processes, how we build our systems, and what we usually do. Okay, complexity is left. What are we doing with the complexity? Well, simplification. I might say, nah, that's too easy. Simplify. That's obvious. Well, it should be obvious, but it's not easy. It's extremely hard. Every moron is able to create an overly complex solution, but it creates a lot of hard work to create a simple one. As strange as it sounds, it is this way. And it's not only hard to create a simple solution. To make things harder, we have to look at the whole IT landscape. It's not about a local optimization. Hey, I simplified my system here. Okay, now you've got a crappy API and all the other ones are suffering from that and becoming more complex. So your simplification overall increased the complexity of the system landscape. That's what's usually happening with projects. Because, hey, yeah, I created the simplest or at least the cheapest solution possible. And yeah, everyone else suffering from that. And so you have to watch the sum and not the summons, which lifts the game at a different level. And you also must be able to distinguish between essential complexity and accidental complexity, the complexity that you need to solve the problem at hand, and all that other complexity that you don't need for that. And just to be clear, requirements are not essential complexity. Usually 70, 80, 90% of your requirements are already accidental complexity because there's a long way between there's a problem and here are the requirements. And company habits and procedures and regulations and governance models and so on make sure that a lot of accidental complexity is usually piled up along the way before it even touches IT. And we have to optimize over time, of course, because IT systems live for a long time. They live for 10 years, 20 years, 50 years. Even I just had did an analysis of an IT system landscape 2 years ago or something like that. Was an insurance company, and their oldest policy system went live 1974, and they won't be able to switch it down for quite a while. So next year, it celebrates its 50th anniversary. So think about that. And it's not only in insurance companies. We see that in a lot of places. So, and we have to address complexity at all levels, starting from how we respond to the market, down to the governance organization and process models, requirements, into the architecture, technology, implementation, improvements. There's a lot of things where we can pile up accidental complexity. I once wrote a blog series about that. and it turned out to become 15 parts plus 3 or 4 complementing parts. So, and these were quite long blog posts. So if you would print that as a book, that would be a 200 pages book, basically. And called the series Simplify. And so what can we do about those things? And that's only what I came up with. And if I come up with 200 pages, so if we put our brains together, then we probably come up with several thousand pages how we can avoid accidental complexity. So, okay. Sustainability, resilience, simplification. Now, I deal quite for a long time with all these 3 topics, meanwhile, in one way or the other. And I always treated them in isolation for a long time. But eventually, I realized something interesting. If you look at these topics in combination, an interesting effect starts to emerge. They start to balance each other, and they start to amplify each other. So it doesn't make too much sense to look at these things in isolation. So, for instance, 2 completely simple examples. So resilient stability. Let's make everything redundant. Replica 3 here, replica 3 there, replica 2 here, replica 5 there, and so on. Because, fault tolerance, failover, blah, blah, blah. Which isn't a bad idea. But in terms of simplification, it's not that good because it makes the system landscape more complex and it makes it more expensive and the ecological footprint becomes worse. So, well, maybe we shouldn't overdo that. Another idea, let's reduce the startup time of our application or our service from 20 seconds to 150 milliseconds. Oh, wow. Now, if something fails, we can simply fire up a new instance. And we can only, if load goes up, we can fire up a new instance when we need it. And we don't need to have 3 instances running because load may go up and stuff like that. Our system landscape becomes simpler and the ecological footprint goes down. And it's even cheaper. And so these things start to, if you look at these things in combination, you see different paths which are more valuable and places which are not that valuable. It's really interesting. In the more valuable paths, usually the effects multiply up and they work on different places. I call that responsible IT because I lack a better name for that. Sorry, I'm not from Gartner or McKinsey, then the name would have been a lot more fancy, of course, but I'm just an average IT consultant. So, well, it's responsible IT. Now you may look at all this and say, that's interesting too. And maybe it's worth to think about IT having these ideas in my mind and to ponder my decisions, what to make. But that's still very high level. So how can we get started with these things? I mean, it's huge. It's huge. As I said, we could discuss for months about that. And we'll still be going. And that's what we need to be going. And I think there's a lot of things we can do. And there are a lot of examples out there that we can pick up. For instance, I just wrote down a few things that came to my mind. It's just a little bit of a brain dump. So things like automation can help us here, or DevOps, or implementing a learning culture, or more these intellectual tasks like help people understand software. Software is invisible, and usually a lot of crap happens because people don't understand the effects of what they're asking for. Or what they're doing, or accelerate. The DORA metrics can help us. And of course, the green IT movement, also rethinking our incentives. The whole incentive system doesn't work if, we are just incentivized in software development for creating new features, not caring about sustainability, bendability, or anything like that. Well, bad things will happen. Or improving our design skills. I mean, usually whenever something goes wrong, we ask for new technology instead of thinking, well, are there better ways to design things up front, and so on. And as I said, we could discuss about that a lot. We could rearrange that. We could group that. We can create different levels of that. We can add a lot more things. I'm sure there are a lot more things that come to your mind. But looking at the watch, we're running out of time. as I said, I'm happy to discuss it with every one of you because I think we have to do a lot of work in these areas. But the last question I would like to discuss before finishing up is, isn't that just old wine in new skins? I mean, resilience isn't particularly new. Sustainability is not a new topic, at least general sustainability. Simplification, yeah, we do not understand it very well yet, but the cry for it is out there for a while. And the things that you saw on the slide before here, a lot of things look familiar. We know all that stuff. So are you just doing the McKinsey trick? So wrapping some stuff that everybody already knows, giving it a new cool name and trying to sell it to us? I think not really. It depends a little bit on your perspective. I think it's a little bit like with disruptive innovations. This is not a disruptive innovation, but the effect is similar. If you look at disruptive innovations in hindsight, for instance, if you look at mobile phones or at cloud computing or at digital cameras or you name it, whatever disrupted whole businesses, there wasn't anything particularly new, not new technology or anything like groundbreaking innovations in these disruptive innovation. It was just that already well-known parts were taken, the right parts, they were combined in the right way at the right time. And I think it's a little bit like that here. The pieces, they already exist. Most ideas and practices and all these things are out there for quite some time. And it's a good thing because quite some companies implemented parts of that. We can learn a lot of that from them. So in how to do that or how better not to do that. And so from that perspective, you might say, yeah, there's nothing new in there. But I think the combination, this one is different. This one is new, especially if you say, you look at all three of them in combination. And what I learned up to now is, and I'm still on a learning path here, is this is really powerful stuff if you put those three perspectives together, the resilience, sustainability, and the simplification perspective, and really ponder that. Yeah, very interesting things going to happen. Again, I'm also exploring that. It's still on the way on planet, but we need to explore that together. And that brings me to the title of the talk. This things are already there, but it's about the combination of things. Because the title of the talk is based on a quote from William Gibson. The future is already here. It's just not evenly distributed. And I think if we want to be better off with the challenges that we are going to face in the next years, which are already here, but which will become more dominant in the upcoming years, our job will be to tweak that distribution to our favor. Okay, thanks a lot for your time, for your patience, and I'm happy to take questions now.
Thanks a lot, Uwe. And as you said in the beginning, you didn't choose yourself. Actually, we had to convince you with the rest of the committee to do the opening talk. And I think it was a very good choice. And I think it was a good overview and the way you showed us the architecture, the problems of today's IT architecture. There was one actual question over there, and it's about how the complexity changes with the deliberate cyber attacks. So it's not so much the all of the regular things you have to fight with, but someone deliberately trying to break your system down. So it's like you're building your house and someone is already attacking it while you're building it. Could you comment on that? How has that changed over the years? How do you expect it to change the way we build IT systems?
The typical one-sentence answer is shift left security. Yeah, we have to. It becomes essential complexity actually. So we cannot neglect that anymore. I mean, I'm working as a consultant for more than 30 years meanwhile. And all the time when I looked into the CIO predictions for the upcoming year, there was IT security in the top 10 list of CIO topics of the next year. And whenever I came to a company and say, what about your security? Say, yeah, well, that's important, but we don't have time for that. We don't have resources. We don't have money for that, and so on. And yeah, nature changed. Latest after cybercrime became more profitable than drug selling. And that's already, I think, 10 or something more years ago that this became a bigger business than drug selling. And so these days, attacks are the new normal. They're sort of a non-functional requirement. So they are there. And so just having a firewall or something that doesn't help you anymore. So yeah, you have to think about that. That's some kind of complexity which is added, which we unfortunately cannot avoid because the world is not that nice out there. But it's just, yeah, we have to build it in. I mean, it's not a lot of fun, but yeah, it's also part of building a dependable system. If you look up dependability as a quality attribute, it includes security, by the way, which is quite interesting. So, and the discussions about dependability started about, I don't know, 20 years ago. So they were looking quite a lot forward into the future when they started with discussing dependability.
Yeah, IT has learned its lesson there. The interesting thing is we just had an AI conference last week, and then we learned that some companies are not thinking that much about security there. So they doing some of the same mistakes we did in IT 30 years ago when we didn't know better, maybe, if you could say now. We did in IoT when people should have known better 20 or 15 years ago when they started building systems, and they built hardware systems which were much harder to patch and then still had vulnerability in there. And in IT now we have learned, as you said, shift left. We need to have security is important. It is one of the factors if your system is running. But now in AI, it's again, we have some problems there. Oh, there could be adversarial attacks. There could be, that's tricky.
Yeah, it's absolutely, I mean, all these people start up enthusiastic. They want to make something new stuff, better stuff, and improve the world. And they're not even thinking about misusing their ideas when they start up with it. And then, well, other people are around say, hey, how can we misuse that for our advantage?
Right. There came another question up. What factors contribute to making effective and pragmatic decisions in a VUCA environment?
That's a hard one because now we open Pandora's box. I think the best thing to start with is to realize that there's no safe ground anymore. So we do not have requirements, because requirements always imply that we know for sure what's going to work. So let's better think in terms of a hypothesis. So we think that this might work, and here is how we will figure out if it really does work or if it doesn't work. And maybe if we start from this perspective and then try to do everything to learn how to from the users, from our customers, is it really how we expect it to be, or do they say, well, no, we have a different opinion about that? So this continuous learning, and I think if this little bit of humbleness regarding our own ideas and saying we don't know for sure, we have an opinion. Opinions are good, but we know that opinions are limited in being, so they are not necessarily correct. And I think that will help a lot on our way. And if we are lucky, many other things will fall into place if we build up this mindset. But again, it would be a discussion for several hours, I'm afraid, if we want to dive deeper into that one. But I think it's a good starting point.
That's the disadvantage of a virtual conference. If it were an in-person conference, I'd say, let's meet with a beer this evening and discuss this topic further.
I'd love to. I absolutely love to. Maybe next year. Maybe we meet in person.
Maybe next year I won't we don't know, but we will discuss that for sure. We will discuss. And by the way, since we're at it, if you're when, not if, you as a participant fill in your feedback, please give us a note on if you prefer it to be virtual online as it is now, or if you prefer an in-person conference. Yeah, thanks, Uwe. Thanks a lot. I really like the cultural references you had in there, William Gibson, and I understood, okay, Spider-Man had it quite easy. The world is, there's good, there's evil, there's him who has to fight evil. I think the map you drew with all the requirements and all the challenges, it looked a bit like a spider web, and that's much more complex than the world of good and evil. Thanks a lot, Uwe.